What's up, everybody? Welcome back to 8th grade science. In this video, we are starting a new unit. This is our first video that relates to physics, which is the study of motion and forces. It's going to be our focus for about the next 6 weeks. And today, we're focusing on net force and balanced versus unbalanced forces. In the upper right, we'll always have that objective. That's today's objective, okay? Right here, we should have filled this in full group with me or Miss Weedman before we started watching the video. So you do not need to worry about that part because it should already be done. We are going to start here. Our guiding question on the left side is, what are the kinds of forces? There are 4 we will talk about. You can take your pen or pencil and cross through the abbreviation box. We don't need any of that actually today. The first type of force is the applied force. Please write applied in the upper box. Applied just means anything that a human or object does. A good example is right here, pushing a box. The little stick figure pushing a box, that's an applied force. There's something applying the force, okay? The second type of force we're going to talk about is gravity. I think y'all already know what this one means. You can take a second and write your own description or examples if you want. My description or example is going to be a pull towards Earth. This is the force that keeps you on the ground. Gravity is always going to be pulling down on something. If we move over a box, we have a force that is the opposite of the applied force, and this is the friction force. I'm guessing y'all know about this too. If you want, pause the video, take a second, and write your own definition for friction force. My definition, or our definition for friction force, will be opposes motion with rubbing. There's going to be some sort of friction. If you put your hands together and move them back and forth, you can feel friction. It causes heat. The frictional force opposes motion. The last force we are going to talk about is the weirdest force. This one's called the normal force. And what the normal force does is it pushes up from ground. We're actually not going to talk about this one too much, but there's gravity pulling you down, and there's something that's stopping you from going through the ground, right? You still stand on the ground. Gravity's not pulling you into the earth, so that must mean there's another force at play. That's called the normal force. We won't talk about that one very much. Our last guiding question, what is a free body diagram? That's this picture right here we have by this little guy. What a free body diagram is a diagram where you can show forces. We're just going to show 2 forces on this diagram. This is how you do it. From the center of the diagram, I want you to put an arrow pointing left and an arrow pointing right. All right? Each arrow, I want you to do this. An arrow equals a force. Each force gets its own arrow. So anything that's acting on the box gets an arrow. Well, the force pushing to the left is just the human pushing the box. So I want you to write applied right here. That's the applied force, pushing the box to the left. And we know that there's a force that opposes motion called friction, so that's going to go in the opposite direction. The arrow pointing to the right is the friction force. Applied going left, friction going right. This is just a way that we can help understand the forces acting on an object. We're going to work on them on the next page. All right, flip over with me. This should be at the top of your second page, and we're just going to do a few more vocabulary words before I give you an example and you start practicing. First of all, force is measured in units called newtons, named after Isaac Newton, who discovered a lot of stuff in physics, and the abbreviation's an N. You can see it right here, actually. That's going to be our abbreviation for force. Those are the units. Just like meters per second are the units of speed, newtons are the units of force. Finally, this is important. We are talking about the net force, and that's the combination of all forces acting on an object. Our little box friend right here, there's a net force because there's force acting to the left, and there's some force of friction acting to the right. Net force, you have to consider all forces. Finally, right here, the most important point of them all is, how does this impact motion? If you have balanced forces, your object is going to stay at a constant speed. It's not going to slow down. It's not going to get faster. It'd just be like if you and your friend are both pushing on a box at the equal amount of strength, that box is not going to move. It's going to stay constant. But if all of a sudden your friend stops pushing from the other side, the box is going to start accelerating or moving away from you. So if you have balanced forces, there's constant speed. If you have unbalanced forces, it accelerates. All right? I'm going to set you up with an example, and then you're going to do the rest of the side and just keep moving. You can do all the way up to the independent practice after this example. Part 2 directions say, calculate the net force and direction of movement for each object below. Remember, all vectors pointing in the same direction, underline vectors, are added, and all vectors pointing in the opposite direction are subtracted. All vector means in science is an arrow with a direction. So just write vector equals arrow. All right. Now we just have to figure out what we need to do. If arrows are pointing in the same direction, you add them. They're in opposite directions, you subtract them. Here's how I want us to do these problems. I'll do one, and I'm setting you free. First thing on number 1, we need to identify what 2 directions the arrows are going, because I see them going in 2 directions. You want to pay attention to the arrowhead. So here this arrowhead's pointing up, so that's an upward force. I'm just going to do that label, up, because I know there's at least one force pointing up. Then I come down here and I actually have 2 arrowheads pointing down. So I'm going to make a second heading called down. Then I need to total up all my forces pointing up and subtract them from all my forces pointing down to see which one wins. Someone's pulling the box up, someone's pulling the box down, which is greater. Well, my upward force, there's only one arrow. It's 167 newtons. My downward force has 2 arrows, 150 and 60. So in total, those arrows are pointing the same way. I'm going to add them. I have a downward force of 210 newtons and an upward force of 167 newtons. Now to get the net force, all we do is subtract the big force from the small force. So we're going to subtract 210 minus 167. I want you to pause the video, do that subtraction. Now that we are back, we know, that the answer here is 43 newtons. So I can copy that to my line. But this is not a complete answer. You need, on every force, every net force problem, a direction. Which number was bigger? 43 newtons 1 was the bigger number. It was 210, which was pointing down. So my net force is 43 newtons down. As you move forward, there's a second example here, third example here. What you need to do is take this 15 and move it to this arrow. It just misprinted. 15 belongs there. Okay? Try calculating the net force and direction for 2 and 3, and then come down to the next stage. Here it says, answer and record the following information for the diagram below. Calculate and record the net force. It's just what we did. Are the forces balanced or unbalanced? If they're balanced, our net force is 0. It's not moving anywhere. So if you get a net force of 0, in B, you'll say it's balanced. If it's not 0, you'll say they're unbalanced. That's really important. Finally, in C, how are the forces affecting the motion? You just need to tell me which direction. If the forces are balanced, it won't move. There's no motion. That'll go in C. If the forces are unbalanced, it'll move either left, right, up, or down. You need to calculate the net force and tell me which direction. That's for 1 and 2. Then you have a bunch more examples where you can just work through the packet all the way up to independent practice. If you get here during our work time, I want you to stop, raise your hand, and come give your packet a check. All right? You can begin working. Good luck.